Okay, thank you all to be here. First of all, thanks to the organizer to give me the opportunity to stay here today. My name is Sergio. I'm a QA staff engineer at Aircall, and my mission there is managing the framework about iOS and Android applications. As you know, the testing is not about running test cases. It's not our only mission. It's about efficiency, it's about scalability, it's about taking the infrastructure, the right infrastructure decisions. So today, I want to talk about what's working, what's not, and why we, in our company, we are taking some decision about the testing automation. So this is all the points I want to talk about. I don't care, I will be fast. First of all, a brief intro about the company and why it's important about our decisions. Next, we'll talk about the device farm, the pros and the cons about an in-house or a cloud-based solution. The third point is the performance bottlenecks we need to detect when we decide to use a device farm. The last point is about efficiency and strategy in our test, and to finish, a brief conclusion about all the points. Okay, before jumping into details, I'm going to give a quick overview about what's Aircall. Aircall is a cloud-based phone system and customer communication platform designed primarily for sales and support teams. In resume, we are receiving calls, and we are sending and we are receiving SMS and MMS. Later, if you talk with sales, we have a lot of features, a lot of integration, whatever. But it's basically the thing we are doing. And we are using the VoIP communication. Later, we will talk about why it's important for us, and it's a critical point in the testing. So when we start with the automation, we take in account that we are taking a lot of time executing the test cases. Maybe one test is taking 3 minutes, 2 minutes, because you need to enable the quick driver agent or installing the application. So what was the decision? The decision was parallelize the work. And how to parallelize? Using a device farm. What is a device farm? A device farm is basically a host connected with some devices. It's basically the thing is. And which is the host? The host can be a cloud solution, or the host can be, if you want to automate Android, you can choose from a Raspberry until, I don't know, a MacBook. But if you want to automate something in Apple, you need to use Apple. From MacBook, Mac Mini, or the server one, the biggest and the expensive one. So let's go with the pros and the cons for each device farm to know which one is needs to use for our company. An in-house solution. An in-house solution has a pros, like you will have direct control over devices and environment. The best for it is you can use it in automate, but if you want to use in manual testing for one reason, for a customer is reporting a bug in that device, you can take it, you can use it, and you can plug in again in the device farm. Next, the complete ownership of data. In some companies, doesn't like to send the application because it's in dev. It can be dangerous, and it's like you are testing in dev or in staging, you have more logs or less restrictions than the production one. So they don't like to send, and you can be the ownership of your data in your office. And fewer third-party dependency. Of course, if you want to use if you need to connect to another one, you are dependent of that provider. With an in-house solution, you only need to take your internet if you need, and that's all. As a cons, It's a higher upfront cost because you need to invest a little bit at first, and you need persons with dedicated technical expertise and dependency with other departments. It's not only a person who manages the device farm. You will need support. You will need SRE. You will need IT to provide you an VPN or an access or a way to connect and to be sure that device farm will work. An external provider will provide you on-demand scalability. If you want to parallelize more, you have the opportunity to parallelize in only a few clicks. You will have variety of devices. It's not only about the parallelization, the variety of devices. It's about maybe you have 3 threads to parallelize, but you can launch first in Pixel, next launch you can launch in Samsung, the next one in another brand. So you can have multiple options to launch in different devices. And no need to purchase or maintain hardware. It's only connect and go. You don't need to maintain the batteries. You don't need to take care about anything. And as a cons, as it's a provider, you can have a potential latency because it's not in real life, it's not in your hand. The subscription fees, of course, if you use it, you need to pay it. And limited control if the provider experiences downtime. The downtime is not only about if the provider is being attacked. If they are updating something in the middle of the night because it's good for them, maybe that night is the most important in the year for you. So you can't launch your test. So once we have the pros and the cons from both, we will see the comparative. The first point, in the comparative is the cost. The cost is the most important thing that your product owner will ask you when you give the options. How much is it? In-house device farm, you will have a high investment at first, but it's lower in long-term costs because it's only you can pay from the MacBook, Mac Mini, the devices, and maybe once per year you need to update the devices or one device if it's new, if it has another size, or in the case of Android, you can buy different brands. And an external client is a continuous high cost. It's expensive, it's a good option, but it's expensive, and it's a subscription-based model. The scalability, as I mentioned before, an in-house device farm is limited by hardware and infrastructure. It's not only the device you buy, it's the device that the host can maintain. You can buy 20 devices, but the host, if it's a MacBook, can take 20 devices and launch in the 21. Maybe there are options, but it's not the best option. An external client farm is easily scalable. You only need to pay more, and you can escalate. The device and OS flexibility, the same as before. You are limited to purchase devices, and in external client farm, you have a dynamic selection of the device. Not only the model, you can buy the model, but if you want to downgrade an OS version in an iPhone, good luck, because maybe in an Android, before it was easier, now it's not the best option, but you can do it. But in iOS, it's a nightmare. The maintenance. In in-house requires the setup and the maintenance. An external client environment, the best point, in my opinion, is you don't need to maintenance. It's handled by the provider. You connect, you use it, and if the devices are broken, it's their problem. The test results and history. An in-house device farm, you will have the full control over data. It's not about sending the app. It's about the results you have. You will have the owner of your results. You can create your own graphs. An external provider provides you that option, but if you finish your contract with the provider, you need to have a way to export the data before, and that data maybe is not in the way you want. Maybe it's a TCP, and you need to use another model, and can be difficult to process. And the execution limit is an in-house device farm. You can use it for when you want. You can launch every time, all the night. An external client farm, maybe they have limits. They can have limits in the manual testing. Maybe they have 30 minutes per device, per session, or you are limited by the threads you can use. And the dependence. In an in-house device farm, you are fully independent. No third-party risk, and the external client farm depend on the provider and the policies they have. So now we have the comparative for all the customers. All the companies can have the same comparative. But in ERCOL, we have another critical point, and it's the VoIP communication. I want to stop here a little to explain how the application is installed in the devices. In an Android, there are no problems. You can have the APK, and you can install wherever you want. But in iOS, you have a problem. To install an application in the iOS, you need to take the UDID of the device. You need to include it in the Apple certificate as developer. Later, you need to sync the app, and now this app can be installed in this device, not in the other. So what's happening? What are the device farm in cloud are doing? They are resigning the app. You send the app, they resign on their certificate, and they can use it in their mobiles, because you can take all the UDIDs they have. It's a good option if you want to use it. But we have a problem with the VoIP certificate. ERCOL has a VoIP certificate that is included in the app. When they resign, the VoIP certificate doesn't match with the certificate of the app, and you can use it, the VoIP. So it's not an option. We need to use an in-house device farm. This is our device farm. It's basically the devices for one hand, and here, the host. And this one is how it's working. I hope the video will play. It's a 7-minute video, so we didn't see all the video. It's only an example. I go to drink a bit. We will see only a few seconds. We are doing mirroring. Okay, it's not a simulator. It's the real devices doing mirroring to check if the device is working in this moment. Because as we are working in remote, we can see the device in real time. So we are doing the login, accepting the permission, and in this specific test, here we are checking that the view is the right one when we are doing the login, clicking on keypad, and now we will launch a call. We can see the laser, no problem. Here is an iPhone 15 Pro executing a test named Combine, and here an iOS 17 with an iPhone 12 Pro. We can stop it. The call is done. Now the test will finish and start again, another one. OK. What was the challenge or the things you need to think before to build a device farm in-house? First, find a good place. You can take the device farm and put it in the middle of the office. First, you have expensive devices, and we know it can be dangerous because it's expensive, basically. So you need to look for a room, a specific room. Better if it's with air conditioner, if it's cooled, because to prevent basically the overheating. Next, the remote access. We are working remote. We need collaboration with other departments. We need a VPN. We need a way to connect to the device farm. Later, we are using the screen share option for Apple. It's working fine. So we can take the control from the computer and later take the control of the device. The third is limited parallelization. As you can see, we have only 5 devices, and it has a reason. And it's not 5 in parallel. We have 3 OS versions, one in iOS 16, I hope will be deprecated our app from there soon, 2 in iOS 17, and 2 in iOS 18. And why? We are using VoIP, so we can't unlimit, we have not unlimited data. We need a real number, we need a real account, so if we want to parallelize with 5, for example, if I receive a call, if 3 devices are using the same account, the third will ring. So 2 of them will fail the test because you receive a pop-up and 2 of them will fail. So we need to create that data, and we have not unlimited numbers because it has a cost. The powered USB. This is a thing we take in account 1 month before create the device farm. The USB have a limited power. So if you try to connect 5 devices in one USB, it can be used for a time, but not forever. So we decided to buy the USB hub. The USB hub is powered, so the USB is maintaining the devices, and the host only needs to take the control over the devices. Because if not, the battery will be down in a few hours. And this is our last. It's a little bit stupid, but it's a fingerbot. This is only for emergencies, OK? It's a bot that can press the power button only for the weekends when there are no people in the office. You can connect to the VPN, and you have a magic card to try to resolve your problem. You can be confident, you can click, it reboot, and maybe it's working, maybe not, but sometimes it can resolve your problems. So we have the device farm. What we need to think about right now. First of all, you need to choose the right framework. I choose only 2 options. I know there are a lot of options to parallelize to do the test. One option was using Espresso for one hand, XCTest for another hand, 2 teams, creating tests, in duplicating our resources, and or use the Appium platform. And as we are in the Appium, of course, we choose Appium. The main reason was our app in Android and iOS has has the same features. As we are using the same features, it has no sense split the resources. So we can focus in one team doing developing the test and using Appium. The second one is the remote access. It's not only create a VPN and have access to the device farm. It's about collaboration. All the team, all the company needs to be involved in the device farm, because maybe you need help from someone that is in the office to reboot, to put the password, or someone else. So you need a right collaboration for all the teams. You can't wait 2 hours, 3 hours to talk with the IT team because you need to open a ticket. It's faster if you have a right communication with them. And the test environment dependencies. We need to minimize the flakiness. How to minimize the flakiness? This is three problems we found using in the day-to-day the device farm. One of the problems we found was the system updates. Sometimes IT asks you for update the MacBook because you have a critical update to be installed because it's secure. You can update or you can do it. If you choose the option from don't do it, they do it. The IT team will do in 10 days, will force the update. What happens when they update your device, your MacBook? It's not only stop the GitLab runner. is because you can have a cron with the GitLab runner when the device firm is reboot. As you know, when the system is updated, you need to go to Xcode, click on it, and a new updates from Xcode, a new tools, a new XC command test, the command line tools needs to be updated. If you didn't update, the test in iOS will fail. So you need manual clicks to update the dependencies. So this one can be resolved updating as soon as possible. Updating from it's possible from Tuesday to Thursday to be sure that there are people in the office and in work hours. The second one point is the pop-ups. The pop-ups in the device. The pop-ups can be, for example, from an update for the system. Can be from it's overheating the device. A way to resolve, or not resolve, is postpone, is rebooting the device. We are rebooting the device after each feature file. After each feature file, we have a command to reboot, to wait the device has been rebooted, and we free the device to execute the next test. We didn't reboot after each test because you are wasting a lot of time. It's about each feature file, and it's fresh for the new test without the pop-up until maybe some hours, but you reboot before. And the third-party services. You can't eliminate all the flaky tests. For me, it's a myth. But you can try to mitigate. So when backend is failing, we have an option to execute the test again. I know it's not the best option to fix the flaky test, but sometimes backend is failing only for a few minutes, for 20 minutes off, because they are updating their libraries, they are updating staging, they are pushing something. So the way we found, and it's working more or less fine, is if you're executing 30 tests and 15 is failing, we have another job in GitLab only executing the 15 we failed before. So after this 15, you have the results, and we have a report with the test execute and the test pass, and the test is not passed. It's important to take in account that you don't need only to review the test fail in the last round. You need to check if the flaky tests are failing only the same test. If failing the same test, maybe there are a feature in the device that is failing only sometimes. You need to review it. So now we have the device farm. We have the potential bottlenecks. We have the API tool. We have the collaboration. We have detected the flakiness. You will detect more flaky tests, but you can try to check how to resolve it or how to mitigate it. And now we need to organize our tests. This is the more complicated point of the meeting. I like to focus on a critical topic. It's about the theory and about the realities. In theory, one test needs to be isolated, simple, fast, short, and one test needs to check only one feature or one point with one assert. But what is happening in the real life? In the real life, and the textbooks, in the real life, we have a problem like we have duplication of steps. As we are duplicating steps, we are wasting time in the same points. So we need a way to reduce that duplication. One bug is taking more than one test fail, is raising more than one failure. Why? Because if you are doing the login and next you are clicking one button and that button is failing, it's not only failing one test. Maybe you find 10 tests failing, and because you are executing 200 tests, and there are a lot of tests, a lot of noise for developers, and you need to try to, in my opinion, execute less tests with more value. And the timing and resources. You have not unlimited timing. If you want to release a version, and you have 200 tests, and that 200 is taking 3 hours, you can execute for the morning. You can raise the ticket when you review in 30 minutes, 1 hour more. You need to open the tickets. The developer needs to check it, need to fix it, have another version. You need to execute again. So you only can launch twice per day. And you have, because the last version, maybe you can launch the test, but you are in home when they finish. So we need to try to minimize that timing. What are we doing? This is an example about a single test, following the theory in the textbooks and in the trainings. For example, the first test is doing the login, clicking on login button, accept the permission, and I log. I check that I am in the right page. The second test is checking, is login and allow permission, clicking on keypad, and I check that I'm in a keypad page. The third one, click on, I do the login, click on keypad, make a call, and I check I'm in the in-call page. The in-call page is working. The call is taking. And the last one is combining the third test. I do the login, I allow the permission, I check I log, I click on keypad, I check the page, I make a call, and I check the page. So we have 3 asserts. What's happening? It's not isolated, it's not simple, it's not fast, it's not short, and one test is checking more than one feature, more than one point. I'm not, and it's about timing, basically, the decision taking. Here we can see the timings, okay? Oh, we can't see the right numbers, but more or less we can show it. The hooks and the login, taking account. We are wasting 15 seconds in the hooks. The hooks is basically uninstalling and installing the app, and maybe installing again the WebDriver agent if it's needed. The login is taking 20 seconds, and we need to do the login in every test. And later, the other steps is taking only a few seconds. It's taking 3, 1, 4 seconds, and the last one, 2. So if we compare the 3 tests, we see as in the combined test, we are using 1 minute and 13. And the others is really similar. It's only a few seconds more the combined test, because it has 3 asserts. But if we take the longest test, because you need to do the login, click, and make the call, it's only 5 seconds more. This is only with 3 tests and combined. But if we export with more features, we show as the red line, the single test, with 9 features, for example, 27 tests, you will take 30 minutes. And in other hand, the combined test is only taking 11. It's a third part of the test. So instead of reviewing the same application 2 times in 1 day, you can use maybe you can execute 4 or 5 test executions for all the day. So to review all the points, you need to understand the trade-offs between in-house and device farm. Not all the companies has the same constraints. You need to think in your company. This is like a football team or soccer for USA teammates. You can use the same strategy with the different players. Identify and address the performance bottlenecks. You need to identify it, and you need to try to mitigate it. Not it's like, OK, yes, another reboot. We can do it because IT needs to reboot. Try to do it something, or try to talk with IT to search, looking for a solution. And apply pragmatic testing strategy to maximize efficiency. We need to save time to take more results in less time. And that's all. If you have questions or something to ask, let me know. This is my LinkedIn. Or if you want to ask, I didn't know. 20 minutes? Oh, 10 minutes, okay. I show fast. Thank you.
Thank you for the presentation, Sergio. Is anyone interested for talk or this? Questions? Okay.
Thank you for the talk. I have a question. Which approach do you have in your company in terms of hardware and the software of the farm? Because there is no real there isn't a lot of alternative on internet. So I have the doubt.
You have a doubt about the alternatives for using a device farm?
Yes. What are you using in your company because it's not only to connect from a DB, for example, to run an Appium. Maybe you want to test it.
If
using the device and that?
We have two options. We can go to the office and take the device. But for example, for Android, it's easier. You have tools to take the control and use it. For iOS, it's more complicated. The test something as manual is really difficult because you need to, you have a way you have a tool, but it's using another Bluetooth to take the control. It's really complicated. The thing I should do it is using the Appium inspector. You can do clicks. If the test is really short, you can do it. If you have a longer one, taking the control from an iOS device and use it as a digital a simulator is not possible by now.
Yeah. Okay, thank you.
Yes, sir.
My question is like, if my team is like, sitting all around the world, right? So how would it work? Basically, because what I'm assuming is that, you cannot have the device farm set up like across all the locations, right? From the latency purpose. So in that case, would the cloud be more good enough for this use case? Like, if I'm right now, let's say my device farm, what you set up, it's in Spain, right? But I'm running my test from US, right? Yeah. In that case, I believe there would be some latency issues, right? Yeah. So what would you suggest on that? Like,
so you are using a device farm in USA and you have lag. There are not too much options for you. If you decide to build a device farm, is the main option to avoid that type of problems. You can use simulator if the company, if the constraints about your company permit use simulator to test something, can be enough. If not, maybe with a VPN, but it depends a lot of your connection and the connection of the provider. Sorry, but there are no more options to avoid the lag.
No worries. Thank you. Yeah.
Any more questions?
Hello, thank you for the presentation. A question, how do you load balance the incoming requests from your CI/CD pipeline, because you have multiple pull requests running against different devices and you have one MacBook where all the devices is linked to?
To launch the test?
Yeah.
We are using the GitLab runner. The GitLab runner permits by now two jobs at the same time. If it's one for iOS 17, another for iOS 18. So we are, if two jobs are coming to be executed in iOS 17, we put in a pile. When the job is finished, the other job is coming, and it's being executed. So we are trying to put in a we limit the jobs in the GitLab runner configuration.
Okay, so you have not have a Selenium grid before Appium?
No. When a job is coming, we launch a command to know how many devices we have, for example, in iOS 17. And if the devices are, if the job is free, take the job for iOS 17. We decide how many devices we have because we can plug more, and we execute in parallel in the devices we have. Once we finish, we take another job from iOS 17. In iOS 18 it's coming, we use the iOS 18 ones.
Okay, thank you.
I know this is that one.
Anyone more?
Hi, thank you. Have you tried to resolve your all problems with browser stack support or source support? Why you haven't tried, why you decided to create your own in-house lab, then use the browser stack supports to resolve the problem with the certificate, as I understand?
We try it a lot.
Why it wasn't possible to resolve?
It's because the VoIP certificate. They are resigning the app to install our app. For Android, you can use it for Android.
It's a technical problem. Why it wasn't possible to resolve it?
They can't, to build our app, you need the VoIP certificate and the certificate of the Apple developer. They only have the tool to resign the Apple certificate. It's not resigning the VoIP certificate. Maybe they have not that type of option. So they are resigning the app to be installed in their devices, and we try to use the VoIP communication, and it's not working. And we try to debug with the browser stack, in this case, developers, and they say that it was about in the trace is because the VoIP certificate was invalidated. So by now, they have no other option. If they resolve that problem, maybe we take the decision to work with another provider.
Okay,
It's easier to me.
Anyone more? No one? Okay, thank you very much.
Thank you.